Last section, we started a discussion on unit conversions with things like distance and time and weight. We're going to continue that conversation focusing on area and volume. So before we get into converting with area and volume, let's just take a little time and review some ideas about area, perimeter, and volume. Activity 1, consider the following floor plan for a living room. What is the perimeter of this room? What is the area of this room? When you find these values, think about the objects you're counting and why you're counting them. So pause the video and think about the area and perimeter of this living room and start the video when you're ready to go. So one of the things we want to focus on is exactly what it is we're counting. So let's go ahead and start with perimeter. So when you're finding the perimeter, you're counting the border, the units of the border, where this is 1 unit. First you have to establish what your unit is. So let's go ahead and call this 1 unit here. So we're going to count how many of those it takes to get all the way around. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the perimeter is 22 units. And we want to be very particular about the label here, where this measurement from here to here constitutes 1 unit. And that would be a unit of length. All right, now let's talk about area. With area, what we're measuring is square units. So we're literally counting how many of these squares are inside the boundary of the living room. And this is going to be what we call 1 square unit. So how many of those do we have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area is 15 square units, which you can write like this. You could write like this. You could spell out square units, whatever makes you happy. If you were to remodel the room, how could the perimeter and the area be used? List a few ideas below. So the motivation here is just thinking about the real life applications of area and perimeter. So if you were remodeling your room, as far as perimeter goes, that would be things like, what's it called, molding. When you put molding around the corners of, or the bottom of your walls, next to your flooring. If you're talking about area, maybe you're gonna get some new carpet. Maybe you're gonna modify the floor plan, like the arrangements of the furniture. That would have to do with area. You'd need to know the perimeter of the room, and then probably multiply it by the height of your walls to, if you were painting. You'd have to figure out the perimeter. You'd have to know area of your walls, not the floor. But so that's just kind of the idea, thinking about how you would use perimeter and area in these real life situations in a living room. So again, the perimeter of a two-dimensional figure is the length of its boundaries. Perimeter is measured in units of length: inches, meters, feet, yards. Area is a two-dimensional figure and is the number of square units. So it could be square inches, square feet, square yards. All right, so here is, by definition, 1 square inch. And this might be almost to scale depending on how it looks on your paper. It's equal to a square. It's an area inside a square that is 1 inch by 1 inch on all sides. So if we want to find the area of this square, we would take its length times its width. So 1 times 1 is 1. An inch times an inch is a square inch. And we get this thing that's a square inch. Okay, so that's why it's called a square inch, because you're multiplying the length times the width, and that's giving you the area. Each grid square has an area of 1 square centimeter. Find the area of each shaded region. Include units in your answer. So what we're saying here is 1 square centimeter is equal to this area right here. I think students struggle sometimes with area because we don't have a tool that measures it. If I want to measure the length of my room, I go get a tape measure or a ruler or something like that. We have actual tools. But if you're going to measure the area of a room, we don't go to the garage and get a whole bunch of these little squares and lay them out on the floor and figure out how many square feet the room is. We use the dimensions of length and width usually to figure out area. So you always have to keep in mind that when you're measuring area, you're literally measuring how many square whatever, centimeters, feet, whatever, would fit inside the boundary of a certain area. All right, why don't you take a minute or two and pause the video and see if you can determine the areas of these shaded regions. Now there's more than one way to get these answers. I put the answers for A and B up here. These are the two most straightforward problems. You can just literally count the squares in A and B, and you should come up with these two answers. When it comes to C and D, it's a little bit trickier because we don't have entire squares. We've got pieces of squares, right? We got this little piece here, we've got a piece here, we've got a piece here. So how do we count the total number of squares? And like I said, there's more than one way to do this, but I'm just going to show you one way to think about this problem. So one way to do this would be to think about putting these two triangles together. So let's say I took this triangle here and this triangle here, and I put them together. So if I took, I'm going to call this triangle 1, I could move it to this position right here. That would be triangle 1. And then I would have these two triangles together make up this rectangle. Then I could count the number of squares in that rectangle, which would be 8. So I have 8 squares in that rectangle, and then I could do the same thing with these two triangles down here. They would go together to make 8. So that would be another 8. So I'd have a total of 16. And like I said, there's more than one way to do this. You could even estimate. You could estimate the number of squares inside one of the triangles. You've got 2 full squares here. So there's 1 and 2. I'm just doing one of the triangles. And then you could say these 2 pieces here go together to make 1. Like this little piece would fit up here. And the same thing with this guy. This goes together to make 1. Maybe let me count by ones. Let me move this 2. So that's another way to visualize that there's 4 square centimeters in each triangle. All right, let's look at D. Now there's multiple ways to do D as well, but one thing I noticed right out of the gate is that C and D are related. D is really the white part, the inside part of C, right? That's what D is. So if I look at the outside border of C, it is what, 6 units long? So from here to here is 6, and from here to here is 6. So everything inside that big square has an area of 36 square centimeters. And then we just determined that the blue shaded part here, these triangles, was 16 square centimeters. So if I subtract that out, I should end up with what's in the middle, oopsie, which is what D is representing. And so that would give me 20 square centimeters. Did you do it a different way? Maybe you did. All right, maybe you cut this up like this. I don't know. Cut it up. Anybody cut it up like that? That's kind of fun. And then find all those areas. Right, there's an area of 2. And then this shape right here, that triangle, that's the same as the triangles that we were doing over here in C. So each of those is 4. kind of fun. I like area, different ways to look at things and think about things. So if we add all those up, what do we have? Let's see, we would get 18. We're supposed to get 20. Where's my mistake? Oh, I think I see it. The easiest part right here. This middle part right here, that's not 2 squares, is it? Some of you were just yelling at the video. No, Chris, that's 4 squares. Okay, got it. But that's kind of a neat way to, when you do things 2 different ways, you can check. You have a way to check your work. So actually, I'm kind of glad that that happened, so we could see, oh, you know, that's a good way to check my work. Where's my mistake? I love doing things more than one way and seeing it come out the same. Or not, and then finding my mistake. All right, so now we have 24 plus 4 plus 5. All right, 4 times 5 is 20. Awesome. So that's just another way to do it the other way. All right, well, in the next video, we're going to talk about conversions with area now that we've got our brains thinking about area and perimeter.